I'm Anil Kumar sharing with you a test paper on trigonometry for grade 10 IB students. We'll have 8 questions in this test paper. You can pause the video in between, copy the questions, solve them out, and then look into my suggestion. One of these questions is, determine the altitude of the right triangle with length of hypotenuse as tan x and the base as sin x. I made them multiple choice so that you can select the best answer also. The next one here is, angle of elevation from the point A and B to a 25-meter high window is pi by 4 and pi by 6. Determine the distance between the points A and B. Let me sketch this diagram also that may help you to solve the question, right? So let us say that the points A and B are on the ground somewhere, right? And the angle of elevation is kind of like this. So we can say that it is pi by 4 and pi by 6 from points A and B respectively. So this is A and this is B. You have to find that distance when we are given this height as 25 meters, right? Okay. The next one here is, Anna bakes an apple pie such that each slice has an area of 121 pi by 5 centimeters square. Her pie is baked in a round dish with diameter of 22 centimeters. Determine the exact measure of angle at the top of each slice of pie in radians. Then we have a question here saying, Peter is riding a Ferris wheel with diameter of 16 meters. It makes 6 revolutions every 30 seconds. Find the angular velocity in radians per second. If Peter is on the Ferris wheel for 7 minutes, determine the distance traveled. A multiple choice question. A broken clock has an hour hand that spins 3 times as fast as it should. Model the height of broken clock's hour hand using sine function with the hand starting at 12 if the hand is 4 centimeter long and the axis is 6 meter off the ground. Now the question here is, consider the function y equals to 3 sine 4x minus pi by 2. Determine period and time. Determine time period and phase shift. So period means time period and phase shift. One cycle of a sine wave begins at x equals to minus pi by 4 and ends at x equals to pi by 3. Determine time period and phase shift. Now here is a question also from my subscriber. I added at the end. Prove the identity cos x over secant x minus sin x over cotangent x is equal to cos x cotangent x minus tan x over cosecant x. So I hope you have copied all the questions, try them out, and then look into my suggestion. Now let us try to solve all these questions one by one. The very first question is, determine the altitude of the right triangle with length of hypotenuse as tan x and the base as sin x. So we have a diagram here. We need to find this particular height. So let me say height or altitude. Now using Pythagorean theorem, we can write height as equal to square root of tan square x minus sin x square. So that becomes the height. Now if I write tan as sine over cos, I get sine square x over cos square x minus sine square x. Everything within square root. We can take cos square x as common denominator, and we get sine square x minus sine to the power of 4x. I mean sine square x and cos square x, sorry. Okay. So now we can actually take sine square x common. Cos square x in the denominator square root can be taken out. Right? So what we can do here is we get sine, let's do it in two steps. Sine square x, 1 minus cos square x. And the denominator is cos square x. Everything is within square root. Now, sine square x, it could be written as sine square x. 1 minus cos square x is also sine square x. So we'll also write this as sine square x. And we have here cos square x. Okay. So now sine square x times sine square x within square root, we can take sine square x outside. Cos square x within square root is cos x. While sine square x over cos x is not an option here. So what we can do here is we can try to match with what is given to us. So let us rewrite this. So I could rewrite this as sine x over cos x divided by sine x. Does make sense to you? Cos x divided by sine x is cotangent x, right? So now I could say that option A is the right option. Since that gives me equal to, so this is equal to sine x divided by cos over sine is cot x, which is our option A, right? So that is how we could actually solve this particular question. Now let's move on. The question here is, angle of elevation from the points A and B to a 25-meter high window is pi by 4 and pi by 6. Determine the distance A to B. So what we can do here is, let's call this point as, let's say O. In that case, we can apply tan and then find what AO and BO is. And then from there we can find what BA is. So basically we need to find what is BA. So B to A can be written as B to O minus AO, right? Now this is a right triangle, and in a right triangle we know tan of an angle, let's say theta, is equals to opposite side over adjacent side, right? So adjacent side is equal to opposite side over tan of the angle. So in this case, BO is this side. So looking into a bigger triangle, we can write B to O as 25 meters, which is opposite side, divided by tan of angle, which is pi by 6. Right? Minus A to O is again 25 over tan of angle pi by 4. Correct? Now calculator is not allowed for this particular test. We'll actually make our special triangles and then figure it out. So we can always use pi by 4 and pi by 6 triangle. So if I use pi by 4, these two sides are equal. 1 square root 2. So we know tan pi by 4 is 1, correct? For pi by 6, this is pi by 3, this is pi by 6. 1, 2 and square root 3 are the sides. So we'll substitute these values. So what we have here is 25 over tan of pi by 6. Tan is opposite over adjacent. It is 1 over square root 3. 1 over square root 3. Minus 25 over tan of pi by 4. 1 over 1, which is 1. Correct? Now that could be written as 25 times square root 3 minus 25. You can take 25 common, right? And what you get here is square root 3 minus 1. The units will be in meters. So that becomes the answer. So the length AB is equal to 25 times square root 3 minus 1 meters. The next question here is, Anna bakes an apple pie such that each slice has an area of 121 pi over 5 centimeters square. Her pie is baked in a round dish with a diameter of 22 centimeters. Determine the exact measure of angle at the top of each slice of pie in radians. So what we are given here is kind of like this. Let's say this is the round dish where the diameter is 22 centimeters, correct? Okay. Now we're talking about a slice. So let's say this is the slice. Radius will be 11, perfect. Now says Anna bakes an apple pie such that slice has an area. So we are given the area of this slice. Correct. We need to find the angle in this particular case. So let's say the angle is theta. Okay. Now, there are a couple of ways to do this. One, we know that area of a circle is actually pi r square. Now that becomes a sector with angle theta, for example. So we say area of this sector, we say sector, will be a ratio of this pi r square times, depending on the angle, theta over total angle is 2 pi. So that becomes the formula for area. So if you don't remember the formula, this is a good way of doing it. Now you could always simplify this, cancelling pi. Now the angle is in radians, which we need, right? Angle in radians. So we get this as half theta r square. So that's the area of a sector formula. Now in our case, we know that radius r is equals to half of 22, right? 22 divided by 2, which is 11 centimeters. We know that. And we need to find theta. And we also know area is 121 pi by 4. So let's write down 121 pi by 5, which is the area, is equal to half of theta we want to know, 11 square, since r is 11, correct? Now 11 square is 121, so that cancels. And we get the value of theta as 2 over 5 pi equals to theta, right? So our answer is theta equals to 2 over 5 pi radians. The next question here is about a Ferris wheel. I'd like you to pause the video, copy the question, try it out, and then look into my suggestions. Well, the question here is, Peter is riding a Ferris wheel with diameter of 16 meters. It makes 6 revolutions every 30 seconds. So we are given diameter as 16 meters. That means radius is half, 8 meters. And we are also given it makes 6 revolutions in 30 seconds. 6 revolutions in 30 seconds. Okay. What do we need to find? Find the angular velocity in radians per second. So first thing we need to find is angular velocity omega, and the unit should be radians per second. And second is, if Peter is on the Ferris wheel for 7 minutes, determine the distance traveled. Now, omega we want in radians per second. So basically, we want to convert this 6 revolutions in 30 seconds into radians per second. So we could write this as 6 revolutions in 30 seconds. So we don't want revolutions, but we want radians. What is 1 revolution equal to? 1 revolution is 2 pi radians, correct? So that's the easy way of converting the units without remembering anything. Do you see that? Revolution, revolution cancel out. And we could simplify this. 6 goes 5 times. So what we get here is omega, angular velocity, is equal to 2 pi by 5 radians per second. Correct? So we got part A. Now let's look into part B now. If Peter is on Ferris wheel for 7 minutes, determine the distance traveled. Now there are 2 ways in which we could do this, right? So one, we could use omega itself, and one, we could start right from the very beginning. So if Peter is on the Ferris wheel for 7 minutes, determine distance traveled. So basically we want distance in 7 minutes. Is it okay? Now what we are given also is 6 revolutions in 30 seconds. So we know 6 revolutions in 30 seconds. That means 12 revolutions in 1 minute. Is it okay? So in 7 minutes, how many revolutions? So 12 times 7, which is 84 revolutions in 7 minutes. Is it okay? So if you do so many revolutions, each revolution is how much? 2 pi r, correct? So each is 2 pi r, circumference. We know circumference, right? Is 2 pi r. This is per revolution. And that has to be multiplied by 84 to get total distance traveled, right? So circumference is 2 pi r, which is in 1 revolution. Is it okay? So in 84 revolutions, distance traveled will be 2 pi r times 84. Does it make sense to you? So that is one way of doing it. R we know is 8, correct? So we can multiply all these numbers, which is 2 times, let me write pi at the end, 2 times 8 times 84 pi. And the units will be in meters. Perfect. So that becomes one answer. The other answer we could get from omega itself. Now omega is 2 pi by 5 radians per second. Now we know arc length A equals to r times theta. Now we can find theta using omega t. So we could write this as r times omega is the speed. If I multiply by time, then we get the angle, and so we can find the total distance. So that gives me r in our case is radius of 8 meters, right? Omega is 2 pi by 5. Now this is radians per second. So as far as time is concerned, 7 minutes should be converted to seconds, right? So 7 times 60. So that becomes the alternate way of finding this answer, correct? So you could do either method, you will get the same answer, right? So that is 12. So you could multiply all these numbers to get your answer. So let's do this, right? So what we have here is 8 times 2 as 16. So we have 8 times 2 as 16. And 7 times 12, let me write 7 times 12 is 84. So I'll multiply 84 by 16. And of course pi at the end. 6 times 4, 24, 2. 6 times 8, 48, and 2 is 50. And 1 times it is 84. Add them up, 4, 4, and 8, 8, 5, 13. So we get our answer as 1344 pi, don't forget pi, meters, correct? So that becomes the total distance. We have exactly the same terms here. 2 times 8 is 16 times 84 pi in meters. Do you see that? So you could do this by basic definition also. Even if you forget the formulas, it is not difficult. So that's the beauty of working in radians. I hope you appreciate it. Let's move on. The next question here is, a broken clock has an hour hand that spins 3 times as fast as it should. Model the height of the broken clock's hour hand using sine function with the hand starting at 12 if the hand is 4 centimeter long and the axis is 6 meters off the ground. So the situation here is kind of like this. We have a clock here and it is like kind of here. We are also given that the hour hand starts with this position and the distances are, this is 4 in centimeters. 6 meters will mean 600 centimeters. Is it okay? So that is the axis. Okay, so this is what is given to us. We are also provided with the information that the hour hand spins 3 times as fast as it should. That means 3 revolutions in 1 hour. That is the speed which it is going. Is it okay? So that means time period t is how much? 1 revolution in 1/3 of an hour. So that becomes the time period. So we can find the value of k, which is 2 pi by t, and that gives you 2 pi by 1/3, which is 6 pi. 6 pi is the value of k. So 6 pi, so we are looking for one of these. Amplitude is 4, so that is correct for all. We want a sine function starting from the top. So if you see, the wave is going to be kind of, if we sketch it here, it will be starting from the top. So, I mean, think this is like axis, right? So in that case, the wave will be kind of like this. So sine wave actually starts quarter of the period before. So we need plus here for phase shift, right? Plus. So plus, okay, so both are plus. So both seems to be correct for us. How much it should be? Quarter of the time period. So time period is 1/3. So that is t over 4. So t over 4 is 1/3 times 1/4 of it, which is 1/12. So that means that portion is correct. And since the axis is 600 centimeters, 600 centimeters is the correct option. So therefore, option A is the correct option. So we get 4 sine 6 pi, x plus 1/12 plus 600 as the correct choice, correct? Okay, so let's move on. Here is the next question for you. Consider the function y equals to 3 sine 4x minus pi by 2. Determine time period and phase shift. 4 choices are given to us. We should rewrite this function. So this function should be written as y equals to 3 sine. Take 4 as a common factor. Otherwise, you'll write the wrong answer. Minus pi by 8, right? Now I think it's very clear. What is the time period? time period t is 2 pi by k, which is 4, and that should be pi by 2. So pi by 2 is the time period, and we have pi by 8 to write. So pi by 2 and pi by 8 to the right. So that is the option C to us. So we are almost at the end. I hope you are enjoying this journey of learning trigonometry with these simple questions. One cycle of sine wave begins at x equals to minus pi by 4. So let me make a sine wave here, then we'll talk about it. So the cycle begins at x equals to minus pi by 4 and ends at pi by 3. Determine time period and phase shift. Well, since it begins at minus pi by 4, that means it is pi by 4 to left. Is it okay? As far as time period is concerned, that is difference of these two positions. So time period t is pi by 3 minus of minus pi by 4. That gives you common denominator of 12. 4 plus 3 pi, right? Common. Let me write like this. That means 7 pi by 12. So 7 pi by 12 and pi by 4 to left. Write the correct option here now. So it should be 7 pi by 12 as the time period, and it should be pi by 4 left as the phase shift, right? So option E is the correct option. Now here is the last question of our test. We need to prove the identity cos x over secant x minus sin x over cotangent x is equals to cos x cot x minus tan x divided by cosecant x. Now we can begin from left hand side, simplify that expression, and then we can also start with right hand side and simplify, and then we can match, right? So the left hand side here is cos x over secant x. Let me first copy this, minus sin x over cot x. Now secant x is 1 over cos, so I could write this as cos x over 1 over cos x minus sin x over cotangent is cos over sine, right? So that gives us cos square x minus sin square x over cos x, and we can actually take common denominator of cos x and we'll get cos cube x minus sin square x. So that is what we get on the left side. Let us also see what we can do with the right side. Right side given to us is cos x cotangent x minus tan x over cosecant x, right? So we could write this as cos x, cot is cos over sine, minus sine over cos, divided by cosecant x is as good as multiplying by sine x, correct? Okay, so let's open the bracket now. So if you open, you get cos square x minus, here you get sin square x over cos x. Well, it's exactly same as this one, right? So you could take common denominator if you want to, and you still get cos cube x minus sin square x. So what you see here is that both left side and right side are equal, so we can say it's hence proved. So actually at this stage also it is kind of same thing. So there is no need of simplifying it further. That is good enough. So I hope with this you understand how we can do a test on trigonometry where we took few questions on radians, area of a sector, angular velocity, solving a trigonometric equation in different ways, and few multiple choice and modeling of a trigonometric function. Feel free to write your suggestions and comments. If you share, like, and subscribe to my videos, that'd be great. Thank you and all the best.